Alright, hello everyone and welcome to the first video for Computer Science Society. I'm going to be making a video for every lesson every week. So if you missed the meeting or if you want to review the content, you can come and watch this video. And I'll be covering the exact same things in the meetings as I will in this video. Well, except for the interactions and like the questions that you guys may ask. But I go through everything in these slides. So if you miss a meeting, you're probably fine because you can watch this video. Anyways, yeah, welcome to CS Society. And this year we have a really exciting curriculum because for the first time we're going to be teaching Berkeley CSS 2.8, and then in semester 2 we're going to have 2 camps, an AI camp and a WWDC camp. So if you're not in the Schoology group, make sure that you join the Schoology group with this code. Let me just make this window float on top. Alright, and alright, so humans of CSS. Who are we? Well, we have John Chen as a TA for the first semester, the Python course. He's going to be a TA. And Michael Lin, he's going to be the instructor for the WWDC bootcamp, as he won the scholarship last year. He was actually a member of the WWDC bootcamp last year too. And so I recruited him this year. And me, I'm going to be the instructor for the S1 Python course and the 2 other camps in semester 2. And Jun Chen, he's the manager for the AI camp because he used to be the president for machine learning club, but ML club got merged with us, so now he's the manager for AI camp. And Eugene, he just came back from Berkeley. He took the 618 course as well, so he's going to be the instructor with me for semester 1 for the Python course. Alright, so let's take a look at what is computer science. So when we talk about computer science, we think about problems like these. What problems can we solve using computation? How do we solve these problems using computers? And what techniques lead to effective solutions? And these questions can be applied to fields like these listed below: systems, AI, graphics, security, networking, and such. And if I'm going to give an example of what I can think of from my life, well, I actually write a lot of programs on my TI-84. For instance, for chemistry, like I would want to code the entire periodic table into my TI-84, so it's easy to find out like the average atomic mass of all the elements. And using that, I can combine it with other algorithms, so then it can automatically tell me, like, for instance, what is the mass of a certain compound. And so what are we going to do here in Computer Science Society? Well, first, it's a class that's going to teach you about programming and computer science. So as you guys all know, in semester 1 we're teaching Python. In semester 2 we're going to do iOS or artificial intelligence. So you're going to be mastering abstraction here. What does abstraction mean? So think about using your phones. The phone, what you use is the interface, and how the interface is implemented and how everything works is abstracted away, as we say. So you don't know how it's implemented, but you know how to use it. But as you join this club, you're becoming programmers, you're becoming builders. So you're going to be building those interfaces instead of only using them as users. So that's why you have to be able to abstract the implementation away, so that the things you build is easy for other people to use. They only need to know how to use the interface. They don't need to know how the implementation works. We're also going to be talking about programming paradigms in this club's course. So you'll be introduced to things such as recursion and also object-oriented programming. So you have a comprehensive understanding of the Python fundamentals. And this is also a club that expects a lot of commitment from the members, because you'll be combining multiple ideas in large projects. We're going to have a large project for the October break, I believe. And we're also going to have challenging assignments weekly. So by the time this video is up, you guys probably already noticed that Lab 1 and Challenge Up is up. Challenge 1 is up. So what's going to happen is that for each lesson, we're going to have a lab, which just asks you to apply the concepts we learned in class to problems. It's going to be pretty straightforward. But for challenge problems, it's going to require a bit more thinking. And also, we're going to be a team that goes to competitions and solves problems together. I'm still looking for hackathons that we can attend together, because it seems that there's not a lot of hackathons in Shanghai, like for high schoolers. And but I'm still looking. So if there's any hackathons, I'll definitely bring you guys together, for you guys to attend the hackathons together. And everyone will register for contests, especially the lead code contests. Those are easy to do. So after we finish, after we start wrapping up with Python, you guys will register for the lead code contests. And also, we're gonna do USACO starting in December. This is also a place where you can work towards a tangible goal. So you guys all know that for the WWDC bootcamp in semester 2, if you build like a good enough project and apply for the scholarship, then there's a chance of you winning the scholarship, so that you can go to Apple's headquarters. No, not Apple's headquarters. You can go to their conference, which is in San Jose in June. And the other path to take is machine learning. So after taking the machine learning bootcamp, you'll be able to build like machine learning projects, such as like image classifiers. All right, moving on to club logistics. First, the structure of the club. So in semester 1, we're going to be learning the basics of programming, because we know that there's a lot of beginners here, so we want to set everyone up for success in semester 2. So we're all gonna be doing Python. We're gonna be learning the basic syntax. We'll introduce you guys to the programming paradigms, and also you'll learn about like some basic data types. Starting December, USACO will open its portal for registration, I believe. I think it's in the middle of winter break, but we can talk about that later. And for lead code contests, those are easy to join, because it's just on the lead code website, and everyone can do them, because there's a range of easy to hard problems, and I'm sure that like after learning about Python, everyone will be able to do some easy problems, and some of you might even be able to solve medium or hard problems. So in semester 2, there's going to be 2 paths, as I mentioned previously. So first is Swift. We'll be learning about iOS development using the Swift programming language. Everyone's going to build a Swift playground project by the end, and using that project and 2 essays that you have to write, you send those to Apple, and in like after you send them in like a week or 2, they'll give you a reply of whether you won the scholarship. And if you do win the scholarship, then you'll be going to San Jose in June to join the Worldwide Developers Conference. The other path to take is the AI bootcamp. So this is for those who want to like obviously do data analysis or machine learning in the future, and we do require you to have taken a calculus course if you want to join this club at this camp, because I'm actually gonna explain all the math behind these algorithms. So yeah, if you're like a junior or senior that's taking calculus, then you can join this club, this camp, and we'll teach you about we'll start from the basics like regression, linear regression, logistic regression, then we'll move on to neural networks, and set you up for college level AI courses. All right, now more about the Python course. So essentially, we teach a simplified version of CS61A, and during semesters, Berkeley have around like 2,000 people that's enrolled in CS61A every semester, and it's definitely the most popular course over there at Berkeley. And this is how the course overview looks like. Every week we'll center around a theme with a specific set of goals. So for the first week, we're gonna introduce you guys to the fundamentals of programming with Python, and those 2 assignments, the lab and the challenge, are gonna help you become comfortable with Python. So this is the course format. Every Wednesday during Extend Learning, I think there's not Club 4, Club 1. So I think there's 1 meeting that's on a Club 1 day, but the rest are on Wednesdays extended learnings. So it's going to be 45 minutes during the Flexi, and there's going to be 7 programming assignments and 1 programming project for October break. And tutoring will be in conference room during Friday Flexi. So basically, I'm just going to be sitting in the library's conference room on Friday Flexis, and you can just come look for me if you have any questions. The entire curriculum will be posted on my blog, and the updates will be posted there too. There's gonna be a lot of course support, and this, I think that this is a great community because you guys have me as an instructor, but also 2 other TAs, and later on we're gonna split you guys into discussion groups, and I think that if you have any questions, you can just directly ask your TAs, and they'll give you a lot of support. All right, yeah, discussion groups. So during the meeting, we're gonna be splitting everyone into groups of 6. This is because if we have like a huge group with like 20 people in it, it's gonna be really intimidating for everyone to ask questions, and it's just kind of too big and hard to manage. So that's why we're splitting everyone into groups of 6. So so there's actually 18 students for semester 1 because 2 execs, June and Michael, they're gonna be students for S1, but they're gonna be instructors for S2 because they haven't learned Python, but they would like to learn Python. And in your discussion groups, you're assigned to a TA who's responsible for checking in with you occasionally to see how you're doing. So if you have any questions, make sure you ask in your discussion groups first, and your TA or your peers will probably reply to you in the chat. If it's like a really, really hard question, which is pretty improbable, then you can ask in the big chat or ask me directly. So yeah, on the meeting, you guys should be able to join your discussion groups. All right, now moving on to club events. So in S1, since we'll mostly be learning Python because there's a lot of beginners, we'll be doing USACO and LeetCode contests towards the end of the semester. So like I believe around December, when everyone has the fundamentals of programming down, then we'll start doing the LeetCode and the USACO stuff. And in S2, USACO will have its round 2 and 3 around January and March, and of course there's also the 2 boot camps. So those who join the WWDC boot camp will be building their playgrounds and learning iOS development, and also applying for the scholarship. And those in the AI boot camp will be learning about the machine learning algorithms and building the projects too towards the end of S2. All right, now a preview of the WWDC boot camp. So it's going to be a 2 to 3 month long boot camp, and you'll be learning the Swift programming language. You're also going to build a Swift playground, which is just a project in Swift, and you're going to apply for the Apple WWDC scholarship. So last year the deadline was, I think, around the end of March. So since school starts in January, we're going to have like a bit more than 2 months in total to learn Swift and build that project. But I think that it's going to be fine because in S1, because last year I actually taught the fundamentals of programming with Swift, then taught people how to build their projects in Swift. And actually, Michael, in fact, won the award. So this year, with you guys learning the Python, learning programming fundamentals in Python in semester 1, then moving on to Swift in semester 2, I'm pretty confident that you guys will do a lot better. And you can also view the curriculum from last year over here on my blog. Here are some images. So I went in 2017 and 2018, and this was in 2017. And this is Michael, who went to WWDC 2019. And this is Craig Federici, and this is Tim Cook. And this is a picture from the article our school posted for us on the SAS WeChat account. And this was last year's members for WWDC Bootcamp. And these are some games that people built last year for the scholarship. And this is Michael's game, and he won the scholarship with this game. And yeah, this is Andrew Yuan's game, which is an AR game, and it's pretty complicated. So this year I think that I'm going to teach you guys how to use SpriteKit mainly, so building 2D games, because these 3D games are pretty complicated to build. Andrew, he had experience working with like 3D modeling and stuff. That's why he could build these stuff. But I'm not a good designer, so I can't 3D model and do that kind of stuff. So I'll be mainly teaching you guys how to use SpriteKit probably, which is for 2D games. All right, so preview of the AI Bootcamp in semester 2. So This is going to be a course based on Andrew Ng's neural networks and deep learning. So it's actually a course on Coursera, and it's like a really popular course because Andrew Ng, he runs a platform called deeplearning.ai, and he teaches a lot of great courses on there. And this is like the introductory course. I took this course. I found that it was really interesting because he actually went into like the how everything works behind the surface. Like he went deep into all the math and the derivatives and stuff. And since it involves multivariable calculus and derivatives, you will have to be the prerequisite will be that you know how to do derivatives and know calculus pretty well. So this is like a really rough plan. So we're gonna start off with linear regression, and then move on to logistic regression, which becomes the building blocks of neural networks. And after that, you guys will build your own projects. So what can you do with the skills taught in the AI bootcamp? Well, using neural networks and even just logistic regression, you can build image classifiers, which is in the field of CV, computer vision. And this is like a meme from Silicon Valley. So this person called Jin Yang, he built like a image classifier that detects whether an object is a hot dog or not a hot dog. You can also do stuff like predicting trends in financial markets, which is under quantitative finance. So this is like actually a project that I'm doing right now, and I sort of just like predicted the SP 500 curve using like 10 stocks that is selected from the US stock market. Or you could just analyze any sort of data. So it's pretty fun to do so. All right, now we're gonna actually start looking at programming. And what I like to do is I like to approach programming through math because not everyone knows about coding, but I think that everyone here, well, everyone in the club is familiar with math since we all took math. So programming and math have a lot in similar, so we're gonna start looking at the expressions and operators. All right, so let's now look at expressions in math. An expression describes a computation and evaluates the value. So you can see that all of these are expressions in math. Although it involves operations and computations, like the plus sign, which adds together 20 and 17, we know that if we look at it as a whole, it ultimately evaluates to a value. So this is something to keep in mind, that an expression in the end is ultimately a value too, because although it is made of a lot of values and operations, but if we look at one expression as a whole, it's the value ultimately. So keeping that in mind, let's look at what's in a program. Programs work by manipulating values, as in we input something into a program and we want it to output our desired result. In order to do that, we have to manipulate the value around to change it up, do some calculations, and then it can output our desired result. And so in order to manipulate the values, we use expressions. And expressions in programs, as I just said before, evaluates to values, just like math. And note that there's something called primitive expressions. Primitive expressions basically evaluate directly to values with minimal work needed. So what does that mean? Well, it basically means like 20 by itself. You don't need to do any calculations. 20 by itself would be a primitive expression. Or like 2017 itself would be a primitive expression. And later on, when we learn more data types, you'll learn that decimal numbers with decimal places and numbers without decimal places are different data types in programming. So we would call numbers without decimal places integers, just like in math. And real numbers, like with decimal places, we call that a double in Python. So for instance, if you have like a 20.0, that would be a primitive expression too, because it doesn't do any calculations. And here are basically a lot of integers, and an integer by itself is just a primitive expression. All right, so operators. Well, operators, we know that in math we have stuff like square roots, we have plus, we have exponents. these basically just combine primitive expressions together into more complex expressions. Without operators, we can't have like complicated calculations because all you have is like just integers and real numbers, so you can't do calculations without operators. So these are important. Now, operators in programming are a bit different than operators in math. So like in math, we have 20 plus 17, and the plus goes in the middle, right? In programming, these operators actually go before the input, and then the format is basically like this. You have the operator name, parentheses, and then your inputs separated by a comma if there's multiple inputs. And we call this entire thing a call expression. So the steps to evaluating a call expression is, first, you evaluate the operator, and this becomes basically, if you evaluate an operator, it's just a block of functionality, because like add, evaluate, you know that it's just a function that adds two numbers together. And then you start evaluating the operands from left to right. Operands are just inputs. So this is a primitive expression, so 2 is just 2, and then move on to the next. 3 is just 3. Then you apply the operator, a function, to the operands, also known as inputs, also known as arguments. So applying add to 2 and 3, we obtain 5. This is essentially the same as writing 2 plus 3, but in programming, we actually put the operator before the inputs in this format with like parentheses and commas. So that's something that you'll have to be familiarizing yourself with. So this might look really complicated, but think about what's it called? Composite functions in math. So these are basically nested call expressions. Now, as we do with composite functions in math, we evaluate from the inside out. For instance, if you have f of g of x, then you'd evaluate g of x first, and then using that, you use g of x as the input of f of x, and then you would evaluate f of x. So same thing with programming, we evaluate from inside out. So for instance, the most nested call expression is this: multiply 4 and 6. This becomes 24, and then you evaluate this entire thing. This becomes 30, and then you move on to this side, and then this becomes 15, and then you only have one call expression left, and this is 30 plus 15, which is 45. However, we as humans, we can jump and skip around, but in programming, the computer doesn't know how to skip around. So how does the computer know which to evaluate first? Well, you follow the evaluate operator, evaluate operand, and apply rule. So looking at this entire nested call expression, first step, you look at the operator, the outermost operator. This is add, and we know that add is a function. And then we go inside, and then we evaluate the operands. So we see that we start from the leftmost one. So we see that the operand is in fact a call expression too. So what do we do with call expressions? Well, we start over here again. So we turn to step 1. We look at this part. We evaluate the operator. This is add, so it's also a function. And then we go to evaluate operands. So starting from the left one, this is a primitive expression. Evaluate 6. 6 by itself is just 6. All right, now we move on to the second one. Well, the second one we see is another call expression. So go back to the first step, evaluate operator. We see that multiply is a function, it's just multiply. And then we evaluate the operands. These two are primitive expressions. So then 4 and 6 are just 4 and 6. Now we can start applying. So applying multiply to 4 and 6, we obtain 24. And then we return to this level, right? So this is now 24, this is 6. We can apply add to 6 and 24, and we obtain 30. And then after we obtain 30, we come back here, and then the first input, we finished evaluating the first input. So the first input is done evaluating. Now we can move on to the next one. So we see it's another call expression. So go back here, and then multiply two primitive expressions, multiply 3 by 5, that's 15. We go back here. Finally, now we have these two inputs as primitive expressions. We can apply the operator, which is add the 30 and 15, and we obtain 45. Alright, so that's basically all the content you guys need to know for the very first lesson. Just expressions and operators in Python. Now I'm going to take you guys for a look at the very first assignment. So the very first assignment can be found over here on my blog. If you click into CSS 2019-2020, then you see that actually on Schoology I posted an update too, so you'll be able to see like the link to the lab. But anyways, like it's gonna redirect you to over here. So once you come here, you can click on Lab 01, and then it's gonna load there. Okay, so basically this is really long only because it's the very first lesson. Like after this week is definitely not going to be this long, because a lot of the content over here is telling you how to like install Python, install your text editors, how to use terminal, etc. So don't be intimidated by the length of this post. Anyways, in order to get started on your very first assignment, which is a lab, you have to have a text editor installed. I recommend Atom, and then you have to download the zip with the lab files inside. So I'm just gonna click on that. All right. So here, I basically tell you like if you want to review the lesson content, you can come watch this video, which you're watching right now, or you can go look at the slides. And yeah, over here I introduce you to how to use Atom Python, and you install Python using this link, and here's the link to Atom. So after you're done installing these, I teach you how to use the terminal. You can read through these, and this is actually pretty important because we have to know how to use, well, you have to know how to use the terminal in order to actually execute the Python code. Yeah, that's why you need to know how to like change directories, because like if you have a file on the desktop, you have to know like how to get into the desktop directory and access the file and execute it. And then yeah, here I cover the basic programming Python, essentially like what we covered in the slides. So expressions, primitive expressions, and then operators in math, and also operators in Python, for instance these. And oh yeah, I didn't mention these in the slides. So these are actually like occasionally I have extra content in the video, or I mean in the lab, because like the first lesson, there's just not that much time. Like we had to introduce like the club and all this stuff. So I decided to put these stuff in the lab. Essentially what I'm talking about is that like plus, minus, multiply, and divide are special operators. You can use them just like how you use them in a calculator, or how you like write it out. You can use them between the inputs. Like these work like this, fine. So if you want to do plus, multiply, minus, or divide, you can use it between the numbers. And there's also parentheses for the PEMDAS rule. And also three extra operators I introduced to you in the lab are floor division, basically divide and round it down, modulo, which gets you the remainder after division, and exponents, which we all know. Here I teach you how to actually do the assignment. So actually I'm just gonna show you. Alright. So here I have lab01.zip. So if I unzip it, you see that inside you have lab01.py. So this is where you're gonna do your assignment. I'm just gonna open this up with Atom. And then you see that you have a lot of underlines over here and underlines over here. So these are fill in the blank questions, and the actual question is over here. For instance, Q1, 10 plus 2. So what I'm asking is that what would Python display if this line was evaluated? So like here's an example, 1 times 2, then Python would obviously evaluate this expression to 2. So then I would replace, so before it's like this, right? I would replace the underlines with 2. And I would do that for all of these questions. And then in section 2, these are some FRQs, free response questions. So like in this question, I asked you to come up with an creative expression that evaluates the 2019. So over here, you would replace the underline with an expression that evaluates the 2019, and just ignore like these stuff for now, like def and like the parentheses and the colon. These are like keywords that we're going to be learning about next class, so you can ignore these for now. All you need to know is that here's an underline portion, and you just need to replace this with an expression that would evaluate to whatever I ask you to evaluate to over here. And for instance, like looking at the second question, you're given an integer x. So here's a variable x. You're given a variable x. You want to write an expression that would evaluate to the last digit of the integer x. So you don't need to do anything else. You don't need to know like what this means. You don't need to know what this means. You don't need to know what this means. All you need to know is that you're given an integer x, a variable x, and you need to come up with an expression that evaluates to the last digit of this integer x, and you would write it right here, and replacing this underlined part with your expression. All right. So after you complete all the problems, basically like you have to execute the file, right? So what you would do is like you would use a terminal, and then you would go to one sec. That's assignments. All right, cd lab and Python 3. So you execute your file with this. Right now it's not working for me because I just opened up an empty file. But after you're done with all the questions, like after you replace all the underlined parts with your answer, you will be able to run it, and it will look like these. For the free response questions, it would say OK for each successful test case, which is like a test for whether you did the right thing. And it would say like how many passed and how many failed. So here, for instance, if you get everything right, it would say test passed, and all fill in the blanks are correct. But what if you get something wrong? So if you have a fill in the blank that's wrong, it would pop up over here after you execute the file. It would say answer number in section something is wrong. But then test passed indicates that your FRQs are all correct. It's only that the fill in the blank part has an incorrect answer. And if you have an FRQ that's incorrect, then it would output a lot of stars like these, and it would show you like which test cases failed. For instance, like remove last digit 25, it would expect that after removing the 5, it would be a 2, but then actually like it got a 0, something like that. And it would tell you like which question you got wrong. Like for instance, it tells you here that this is the remove last digit question. And lastly, like if you're done with everything and you've taken a screenshot of all the test cases being passed, then you can upload your file over here. Basically, select file, and then enter your name over here, and then you can upload. And I'll mark you as done for that week's homework. And so for homework, I expect you guys to finish one meeting's homework before the next meeting. So for instance, for this meeting, I would expect you to hand in the lab and the challenges screenshots for all the test cases being passed before the next meeting. And that's pretty much it. So I'm hoping to have a really productive year with all of you guys, and thanks for watching the video.